So today we're doing 7-3. So 7-3 is another way. So we know how to solve these with graphing. That was 7-1. 7-2 is on substitution. We're going to do 7-3 all week this week. So hopefully we get it down today. But if you don't get it down today, we'll work on it tomorrow. We're going to work on it Wednesday because you have a short week this week. We're going to go from there. So with 7-3, it is called using substitution with addition and subtraction. It's also known as elimination. Okay. So what we're going to do instead of solving these for one equation, because if you look at the first one, it's not going to be easy to get any of those letters by itself, is it? We don't have just an x or have a y. We have a 3x, we have a negative 5y, we have a positive 5y, and we have a 2x. So we're going to use elimination on problems like this. What you're looking for with elimination is you need either the x values or the y values to be the same number but be opposites, meaning I want, like in number one, notice how they have a negative 5y and a positive 5y. A negative 5y in the top equation, a positive 5y in the bottom equation. That's what I want. I want them to be the same number, but I want them to be opposite. So if I have that, all I need to do is add my two equations together. Because what's going to happen now is what's 3x plus 2x? Okay, if I take negative 5y and I add 5y, do I have any y's left? So that's just gone. You don't even need that anymore. Equals negative 16 plus 31 gives me. So now you're just left with 5x equals 15. So how do I figure out what x equals?
Divide by 5
so
on each side.
X equals 3. There is your x coordinate. Now, to find your y coordinate, pick either equation and plug that in for x. So I'm just going to pick the bottom one. It doesn't matter if it's top or bottom. So 2 times 3 plus 5y equals 31. 6 plus 5y equals 31. How do I get rid of the 6? Minus 6. So 5y equals 25. What's y going to equal? So your coordinate would be 3, 5. It's a little quicker than substitution. So like I said, we're going to do 4 different ways to all do the same thing this chapter. So if this way is something that you like doing, when we get to the chapter test, this is a possible thing you can do. Okay? So when we're looking at the second one now, we need either the x's or the y's to be the same number and to be opposite. So are the x's the same number? Are 2 and 4 the same number? No. Are the y's the same number? 1 and negative 1. Are they opposites? Okay, so I can add these together. What's 2x plus 4x?
6x.
The y's are now going to be gone. What's 18 plus 12? So what's x got to equal? 5. So that's my x coordinate, 5. And I take that and I plug it into either equation. I'm going to go with the top one, okay? Just to show you it doesn't matter. 2 times 5 plus y equals 18. What's 2 times 5? 10 plus y gives me 18. What's y have to be? 8. Your answer is 5, 8. That is elimination. Okay, so like the third one. Now we're wondering what happens if they're not. So if they're not, what we have to look for first, do we have either the x's, well these are s's, but x's or y's, do we have any that are the same number first? Okay, the y's are the same number, that's good. So all I'm going to do is I'm going to multiply the bottom equation then by negative 1. All that's going to do is just change all my signs. So this will be a negative 2y, negative 9s, negative 22. Now are they opposites? So you can add them together. 5 plus negative 9 gives me negative 4s equals 6 minus 22. Negative 16. And how do I get s by itself? Divide by Negative 4. So S is going to be 4. Then you can take that. I'm going to plug it into the top equation. 5 times 4 plus 2y equals 6. What's 5 times 4? 20 plus 2y equals 6. Then what am I going to do? Minus 20. So 2y equals negative 14. Divided by 2, y is going to equal negative 7. So if it's not xy, it just goes alphabetical. So this one's going to be sy. So you're going to go 4, negative 7 is my answer. And you're done.
How are all gonna be the same number?
What do you mean?
Like,
You should have one every time set up to be the same number. So if you look at this next one, I need one of them, doesn't matter which one. If we have 2, that's fine. I need one of them to be the same number and opposite. So the x's, are they the same number?
No.
Are they opposites?
no.
Are the y's the same number? Are they opposites? So I can add these together. What's 1x plus 1x? 2x. The y's are going to cancel out now. Negative 3 plus 1 gives me negative 2. So what's x got to equal? Negative 1. And you just take that, plug it in. Negative 1 plus y equals negative 3. So we add 1. Y is negative 2. Your coordinate would be negative 1, negative 2. Okay? We'll do one more and then we'll see.
If they're both negative, would you just make them positive?
Which one are you looking at?
One the same.
Oh, I see what you're saying. So like this one right here.
Yeah.
Okay, I'll go over one. I'll change these numbers up in a minute. I'll go over one like that. So here, our x is the same number. 4 and 8, are those the same?
No.
Our y is the same number. Are they opposites? So to make it opposite, you literally just go through and you change the sign of everything. Because what you're doing is you're multiplying everything by a negative 1. That's why it changes the sign every time. Now I can add these together. What's 4 plus negative 8?
Everybody wearing black? Can I get their picture quick?
Yeah.
Okay. If you're wearing black, come on here quick. For a picture. Yep, if you're wearing black. Come on out.
Yeah.
Wait, do we have to be in?
Yes.
Let's go.
Okay, so 4 plus negative 8 gives me negative 4x. Negative 7 plus negative 9 gives me negative 16. So what's divided by negative 4? What's x have to equal? 4. Plug that in. 4 times 4 plus 5y equals 7. 16 plus 5y equals 7. How do I get rid of 16? Minus 16. So 5y equals, that's going to be 9 divided by 5. Can I take 9 divided by 5 and get a whole number? Y equals 9 over 5. You're done. Okay. And that is 7-3.